Alright guys, today our lesson is on x and y intercepts. So an x and a y intercept is where a line or a graph crosses the x or the y axis. So my y-axis is the vertical axis. That's my y-axis. This over here, it's already marked as my x-axis. So a y-intercept is where a line touches the y-axis. In this graph, it's this point right here. That is my y-intercept. And it's a coordinate point, so we label it like a coordinate point. That point is called 0, 7. So that is my y-intercept. The x-intercept is where it crosses the x-axis, or the horizontal axis. So this line touches the x-axis right there. That makes that point the x-intercept. That point is called -4, 0. All right, so that's an x and a y-intercept from a graph. They're pretty easy to find on a graph, but the problem is what happens when it's not on a whole number, it's in between. You can't tell if it's at maybe 1.5 or 1 3/4, or if you're just given an equation and you don't have the means to graph it to see where those x and y intercepts are. So we're going to focus on when you're going to have an equation and you have to find the x and the y-intercept. So here's an example of an equation of a line. And if you were asked to find the intercepts, both the x and the y-intercept, the y-intercept would be pretty simple because it's in slope-intercept form. We call it slope-intercept form because in the equation we're given the slope and the y-intercept. So in this case, the y-intercept is -6 because that's what slope-intercept form tells us about it. So the y-intercept is -6. Remember, that's a point on the y-axis, and if we want to list it as a coordinate point, it's 0, -6. Sometimes we just say the y-intercept is -6, but most times we want to say it as a point because it is a point on a coordinate graph. The x-intercept is a little bit trickier. We could graph this line and try to figure out where it crosses the x-axis. And I know it's going to cross the x-axis somewhere over here, if I could graph it and get exactly where. But I know it's going to be at something, 0. That's going to be the coordinate point for the x-axis. It's going to definitely have a number, 0, because anything along the x-axis has a y value of 0. If I plot a random point over here, if this is the first one, this is -1, 0. If I go a little further, this is -2, 0, because I don't go up or down. The y tells you how far up or down to go. So any x-intercept is going to have a y value of 0. Let's write that down. The y is always 0 for an x-intercept. What that means is I'm looking for a point. You do know my y value. I can take this equation and figure that out by plugging in 0 for y and solving for x. So if I know the y value is supposed to be 0, you plug in 0 for y into your equation. And that way you can use your equation and you don't have to graph it to find this x-intercept. We just know that if we're looking for an x-intercept, the y is 0, so replace y with 0, and then solve to see what x would be. We're just going to solve this equation. Divide by 2 and x equals 3. So my x-intercept is 3. What that means is that when y was 0, x was 3. So 3, 0 is my x-intercept. That can actually be done for y-intercepts too if it's not in slope-intercept form, except for a y value, it's x that is always 0. So anytime you have a y-intercept, your x is 0, so you can plug in 0 for x into an equation and solve. If I did that in this example, if I replaced my x with 0, I would get 2 times 0, which is 0, minus 6. That would give me y equals -6, which is what I actually got anyway, because I already knew that that -6 represented the y-intercept. Okay, let's try using this method on a couple new ones. Here we have an equation not in slope-intercept form, so I can't visually just look at it and tell what the x or the y-intercept is. So let's start getting these two values. Let's start with an x-intercept. For an x-intercept, remember, the y value is 0. We know that. Any x-intercept, y is always 0. So we're going to plug in 0 for y. We're going to rewrite this equation, replacing the y with a 0. And we're going to solve for x. So 0 minus 6 is just negative 6 plus 4x equals 8. Add 6 to both sides. 4x equals 14. Divide by 4, and I get that x equals 14 divided by 4, which is 14 over 4. And that's all it is. I can simplify that, but that's a fraction. When you have 14 divided by 4, we just write that as 14 over 4. A fraction is just another way of writing a division problem. I do need to simplify this fraction, though. I can divide both of these by 2, and x equals 7 over 2. As a mixed number, that would be 3.5, and either one is acceptable most of the time. So 7 over 2 or 3.5. That's my x-intercept. That's telling me that when y equals 0, x is 3.5. So my coordinate point is 3.5, comma 0. That's my x-intercept. So because this x-intercept was a fraction, it would have been really hard to look at a graph and tell what the x-intercept is. That's why we need to do it this way using the equation. Okay, let's do the y-intercept next. So for a y-intercept, we know that the x value is always 0. So we're going to plug in 0 for x. I'm going to go back, take this original equation, and I'm just going to rewrite it, but replace the x this time with 0. So here we get 4 times 0 is 0. So I'm left with y minus 6 equals 8. Add 6 to both sides, and y equals 14. That means my y-intercept is 14. So my point is 0, comma 14. When x is 0, y is 14 for this particular equation. All right, let's try it with another one. 3x minus 5y plus 2 equals 0. We'll find both the x and the y-intercepts. Let's start with an x-intercept. For an x-intercept, we're going to plug in 0 for which value? Y. All x-intercepts have a y value of 0. Again, if you forget, sketch a little line, think about where that x-intercept is and what that point would be called. It would be 1, comma 0 or 2, comma 0. Anything with a 0 for the y. All right, so we're going to use our equation and just replace y with 0. Write everything else the way it is. And we're going to solve for x. When we solve for x, that tells us what x is. When y is 0, that is our x-intercept. So this becomes just minus 0. And I have 3x plus 2 equals 0. Subtract 2 from both sides. 3x equals negative 2. Divide by 3, and we get a fraction. Negative 2 doesn't divide evenly by 3, but my answer is just 2 over 3. So my x-intercept is negative 2 over 3. As a that is written as negative 2/3, comma 0. So when x is negative 2/3, y is 0. That falls on the x-axis, and that is the x-intercept of this line. All right, one more. Let's do the y-intercept for this. For a y-intercept, we're going to plug in 0 for this time. It's going to be for x. So for any y-intercept, the x value is 0. We know our point is going to be 0, comma something. So I'm going to take my equation again, rewrite it, but replace the x with 0. All right, so 3 times 0 is just left with minus or negative 5y plus 2 equals 0. Subtract 2 from both sides. Negative 5y equals negative 2. Divide both sides by negative 5. Again, we get a fraction. 2 cannot be divided evenly. Also, if we're dividing a negative 2 divided by a negative 5, or if you have a negative over a negative, that becomes a positive 2/5. 2/5 means the same as 2 divided by 5. So my y-intercept in this case is 2/5, and the point is 0, 2/5. That's where it crosses the y-axis. So that's basically how you find x and y intercepts from an equation. What you're doing is you're plugging in 0 for the other letter. Like if you're getting the x-intercept, you plug in 0 for the y. And you should be solving for x. An x-intercept should have an x value in the end, if that helps you remember it. There should actually be a number for the x other than 0. Now it could be 0, 0, but most of the time it won't. For the y-intercept, you're going to plug in 0 for x, and you're solving for y, so your answer should give you a y. And so that's all there is to finding x and y intercepts.